Welcome to the new cyber frontier, bringing you the latest news and initiatives that focus on the development of cybersecurity economics. You don't have to be a computer or cybersecurity expert to get plugged in. Your host brings it straightforward, asks the tough questions, and brings the cyber world to a level of understanding for everyone. You can find us on the web at www.newcyberfrontier.com. Now join our host as he introduces the topic for today's New Cyber Frontier.
Welcome to today's episode of New Cyber Frontier. On today, I think we have a great show, a great topic that I'm interested in kind of chatting through. But I have as a guest Dr. Brian Smith. Dr. Smith's background as a professor, a PhD from Berkeley, so we know he has some creds here. 5 years as a professor at Cornell, and then a few startups. And that's kind of a lot of what we're going to talk about today. Currently, founder of SpiderBat. And so welcome, Brian. Thanks for joining today.
Yeah, thanks, Chris. Thanks for having me on. I'm looking forward to this.
Definitely. So give us that background. Give us more information. Tell us how you started out. We always like to know how people that are seasoned got their start, their interest before you got to the point you're at now, and then tell us what we're going to talk about with SpiderBat afterwards.
I guess I started Berkeley, and I'm a fallen physicist. So I got an undergrad in physics from Berkeley, and then I discovered that I liked knowing physics a lot more than I liked doing physics. I like building things, and so I started building. I was doing a lot of work in kind of computing and computer science, and got a job actually in the computer science department. Was surrounded by people who were using a bunch of words I didn't know. And so I ended up going back to grad school in computer science and started my career building the first video playback systems back in the late 80s, early 90s. And that took me to Cornell, and then left there in about 1998 with a two-body problem with my wife. She was a professor at also, and started a company with a friend of mine, Mark, which was Tipping Point, which was an intrusion prevention system company back in 2000, 2001. Very high speed. Basically, you cut a wire in the network, plug both ends in, and it acts like a bump in the wire and filters out bad traffic, essentially blocks it. A lot of really interesting challenges. That one got bought by 3Com, started another company with Mark, Click Security. That got bought by Alert Logic, and there I got to see kind of firsthand how a security operations center works. And that was pretty eye-opening. And so realized that it's a very difficult job. It's a kind of a drudgery job in some ways, or can be, and wanted to make it better. And so we started SpiderBat to make it both that job a lot easier, but also to make it applicable to areas that were just not being covered by the cybersecurity, big blank spots in the attack surface. So that's kind of where I came from and how I got here.
Okay, so SpiderBat, Kubernetes, which I've never done a show on Kubernetes. I'm totally interested to hear from an expert in that area, but tell us what that is and what is SpiderBat doing.
Yeah, so Kubernetes is sort of an evolution, the latest step, I guess you would say, in the evolution of cloud systems. So if you think back, roll the Wayback Machine to 20 some odd years ago, we had data centers and we were building physical hardware. Those got virtualized to virtual machines, and we got more efficiency of use because you could stack a couple of different systems on a VM, and then systems began to automate to bring them up and down, and that's what cloud is, right? You can essentially have systems automatically say, oh, I need more DNS servers, and so it'll bring up some more DNS servers for you and say, I've got too many, and should bring them down. That was efficiency. Those begin to take a long time to bring up and tear down, and so people started moving, and along with it, we started moving towards more containerized environments to solve some of that problem. Then orchestrating the containers became a problem, just like orchestrating the VMs. And so Kubernetes is a system that orchestrates the containers for you. And so it can do a lot of, it's almost like a cloud in a box where you're using containers instead of VMs. So it handles the networking, handles bringing up and down containers, like we used to bring up down VMs. And it's a very dynamic environment, because what'll happen is some containers come up and only live for a few seconds and die. Some will be around for 5-10 minutes. So what's happened over time is the lifetime of these things is shortened a lot. You used to have servers, and there's this clouds versus cats versus chickens. Cats versus kind of cats versus chickens. So a server was like a cat. You name it, you take care of it. If it gets sick, you try to bring it back to health. And when it dies, you mourn for it a little bit and bring a new one. Cloud VMs are like chickens. If one gets sick, you just get rid of it and get a new one. So you don't really name them and get too attached to them. Containers are more like ant farms or something. Things come and go, and they're very, very, very quick. And because of that dynamicism, it causes some interesting problems in the security landscape.
All right. Well, let's take a break here from our sponsors. We'll be right back in a minute.
Blockframe Technology offers next-generation blockchain managed trust and security. Unique non-fungible tokens are used to secure software bills of materials to provide data quality and security for every transaction in your supply chain. Deploy advanced peer-to-peer product security, scale zero trust capability to millions of IoT devices, allow vendor tracking and accountability, and rapidly reset from compromise. Unchangeable, time-sequenced blockchain data provides next-generation security using machine learning trust algorithms and audit analytics. Start securing your supply chain today by contacting Blockframe at www.blockframetech.com.
Welcome back to New Cyber Frontier. On today with Dr. Brian Smith, he gave us a good definition before the break on Kubernetes and the management of security in clouds. And so you got down to the ant level. So we don't care. We'll squash these all the time. We'll step on them all day long. So they're not, you don't have any value in the cloud container. We just start them up, burn them whenever we want to.
Yeah, but it's also changed the way people develop software, because we do releases very, very quickly now on cloud. You'll do 50, 100 releases a day. So there's
if it locks up, you just burn. If the software locks up, you just burn that computer, stand up a new one, you go again. You don't have to debug
that or you do, you fix a bug and you kind of immediately push it through the system. Gotcha. So especially in the kind of integration environments where we test these things are coming up and down all the time. People build software and kind of immediately deploy the software into the integration environment, and then it gets tested there. As it works its way through the pipeline, it makes it to production. But people do multiple production releases a week, 10, 20 of them. And so it's a very dynamic environment, but it's allowed a tremendous productivity gains. And it's fun. Yeah. It's fun from a developer standpoint. That's, I think, a lot of the attractiveness. Yeah.
So that's interesting. Now tell me about the security concerns in there and why Kubernetes, what's it doing?
Well, so yeah, I guess if you take a look at the security landscape, how it's evolved over the past 20 years. A lot of the early focus was on Windows. And then everyone who didn't have a Windows systems, like a bunch of my friends who had Macs back then, said, I have a Mac, I'm invulnerable. And then, the attackers found Mac systems and started attacking them. And then we've evolved over attacking mobile devices and other types of systems. And that's where a lot of the energy of the security industry has been focused, is on those things. And comparatively little has been done on Linux systems, and Linux underpins most of the Kubernetes world, most of the cloud world. And so we've got this interesting disconnect where so much of the movement of our software and of our valuables is into cloud systems in Linux. And yet a lot of the security industry has been focused on Windows and protecting desktop devices and so on. And so there was kind of a bit of a dearth there. And so that was a good place to do a startup. And so that's kind of, we started focusing on Kubernetes security. And one of the challenges there is, first off, there's just the way you do things in Windows and Linux is different. So there's an expertise gap. Second thing, though, is that a lot of these attacks are can be very long-lived. They can be in for weeks or months. So that presents a challenge. And that combined with these systems coming and going all the time, where the IP addresses are changing and the software that's running associated with a particular IP or something's changing. A lot of the systems were designed, older systems were designed with Windows and a relatively static environment in mind. And here we have Linux and a very dynamic environment. And it's been difficult to adapt them practically towards the Kubernetes space. But yet it's a big target from an attacker standpoint, because there's a lot of good stuff out there, and it's worth attacking.
So explain briefly, what is Kubernetes? How does it work? What are you doing in the cloud?
Yeah, so the way you build software for Kubernetes, and it is you build you create your software package, and usually it's based on some other image that someone else has built for you. So for example, I might be building my stuff on Node or Python or Ruby or something like that. So I'll take a base Ruby image or a base Python image, and then I'll start to layer on my stuff on it. I maybe need some software packages and some other things. So I built this object that's an image, and that image contains all the different components that I need to make the software work. And then what Kubernetes will do is I'll put that image in a registry with a name and a tag, and then what'll happen is Kubernetes will orchestrate, say, oh, I need a new web server. This is the image for my web server. So it'll pull the image down, instantiate it, and bring up a new Nginx web server running with PHP running on it, for example, and in a what's called a containerized environment, without having to build a server where you actually install all that stuff beforehand. It's all kind of packaged. All that stuff's packaged inside the container. So each of the containers is very different from the other ones. They're all kind of almost like little tiny custom servers. But what's happened is they're what's called microservices. And they're little servers, but they do very specific small things. So for example, in a three-tier, kind of classic three-tier web architecture, database, middleware, web server front end, you would have a container running the web server, and that's all it does is it runs the web server, and it talks to the app layer, and then the app layer talks to the database layer, and all those pieces will be individual containers. And so if I need more database, I scale that up. If I need more app servers, I scale that up. If I need more web servers, I scale that up.
And voila, we have cloud.
And we have cloud, and that can happen 2 or 3 seconds, 5 seconds, the server comes up. So it's very dynamic. But when you're trying to secure those things, every one of those environments is like this completely custom environment. And so that makes it challenging. But there's a light at the end of the tunnel there too, because they're so small in the sense of these containers do kind of one thing. They're just a web server. They're just an app server. It's not like my laptop that does 43 different things. That I do personal email, I do my banking, I do all these different things that I have to secure that are a mishmash, and there's no rhyme or reason to any of it. In the cloud, each of these images is pretty specific in what it does. And so what you can do is that changes our approach to securing these things. And so it's pretty neat when one of the things I love the reason I got into computer science in the first place, I like building things. And the reason that kept me in there is that the rules of the game are constantly changing. If you think about it, back, I don't know, when I was starting, there were these big disk farms with, platters that were, 12-inch platters spinning in a room somewhere, and teletype terminals. Then floppy disks came along, then flash drives came along, then now we have embedded drives, and again, each of those technological changes opens up opportunities to rethink how we do things. There's a lot of principles that we can base all that stuff on, but the principles tend to stay the same, but all the parameters change, and so your designs change. And Kubernetes has allowed us to change the way we think about security systems. So one of the things that I've been thinking a lot about recently is our approach to securing things in the past has typically been prevent as much as we can. And so there's been a lot of focus on the software development lifecycle, vulnerability scanning, just trying to keep your stuff clean.
Mm-hmm.
And then detecting bad stuff, right? So antivirus, and the third pillar is really kind of rule enforcement. That can be everything from processes and procedures to firewalls, and, sort of segmentation type things, authorization segmentation. So if you think about that area of detecting bad stuff, that's runtime protection. Instead of there's a whole portion of it focused on developing software, secure software, and that's important. But then there's detecting bad stuff at runtime. And traditionally what we've done, and I mean, this is what Tipping Point did, is we research the latest threats. You develop some way of detecting that thing. Then when you detect it, you block it or alert on it or take action on it in some form. And that is a problematic way to do things for a bunch of reasons. One of them is that
that's a good place to take a break. We'll hear from our sponsors. We'll be right back because we want to explore that a little bit more. Be right back.
I thought that might actually be it felt about like we were getting there.
Blockframe technology offers next-generation blockchain managed trust and security. Unique non-fungible tokens are used to secure software bills of materials to provide data quality and security for every transaction in your supply chain. Deploy advanced peer-to-peer product security, scale zero trust capability to millions of IoT devices, allow vendor tracking and accountability, and rapidly reset from compromise. Unchangeable, time-sequenced blockchain data provides next-generation security using machine learning trust algorithms and audit analytics. Start securing your supply chain today by contacting Blockframe at www.blockframetech.com.
Welcome back to New Cyber Frontier. On today with Dr. Brian Smith. Before the break, you were starting to get into a new topic. Let's kind of pick up there and let us know where you were going with that.
Yeah. So basically, we're talking about the sort of breakdown of being able securing things through the software development lifecycle, secure software development methods, which is preventative. That's before the software ever runs in a way. And then runtime protection, which is all about watching how it's behaving at runtime and detecting. And the traditional approach runtime detection has been detect bad stuff. When you think about the Windows box that I was talking about before, that's kind of the only practical approach, trying to figure out how that thing behaves normally. There's no normal. It's all over the map. And so there was, but if you look at the way Kubernetes works and the way I was describing these microservices, they tend to be really tiny. They do one thing. And so what you can look at is you can think about developing a set of technologies that allows you to see how a system's running, how it's, what all the activities that are happening on a system. And then I can associate that, all that activity was with this image, with this container, and that container was running this image. And I have 3 examples of that running, 3 different instances of the web server, 3 containers. And then I have 12 different instances of the app server running and so on. And I can build essentially a fingerprint of how that thing works, a profile of how that works. And that's actually small enough and contained enough that a human can understand it. And so we can build that behavioral understanding just by kind of passively observing it into the software development lifecycle, where the developer who's building that thing says, yep, that's my software. All that makes total sense. That's exactly how it should be working. The app server, it should be talking to the database server. It should be getting connections from the web server. All is good. It's talking to this, maybe this authorization server and this partner and whatever it's doing, this ad campaign server. So I can build that profile on it, and I can use that to do enforcement, where if it goes outside of that box, if it's in the integration environment, I might just alert the developer and say, oh yeah, I added that. Let me update the profile and say that it added it. But once it makes to production, then I can use that enforcement and say, stop it. So God forbid my software gets compromised and it starts talking to some server out on the internet and it's trying to take all the credit card data and shuffle it out, or just to another server inside my environment, which is kind of what we've seen. That'll be immediately detected as an aberrant behavior, and you can shut it down. And it's because the way we're developing software allows that to happen now, which it didn't have. That wasn't true in the past. That's what I mean about rethinking.
So we're
things.
we're looking at watching the software run in a box and determining from the operations of that box whether the software is running differently or as expected.
Yeah, exactly. And the neat thing is once you have that watching it in a box, if it does deviate, guess what? You've got an entire recording of everything it's done, everything it did, and how it got there. So it's useful from both the operations standpoint and from the investigation standpoint, figuring out what actually happened and how we got there. And that latter part's really important, because remember I was telling you I was working in the SOC. With the guys, the product we developed in that second company became the front end of this security operations center. So I worked a lot with the SOC guys and got a chance to see how their lives worked. And typically the way that worked was people got an alert. They had 15 minutes to decide, is this real or not? And they pawed through a bunch of log records and trying to prove to themselves as best they can, is this real or is this not? And when the 15 minutes is up, they said, probably not real. Go away and move on. Or, yeah, this feels bad. I need to go. So it was in many cases kind of a squishy thing, and a pretty unsatisfying thing, and just a treadmill, because you're just looking, you're constantly just looking through the logs, and you get on to the next 15 minutes and the next 15 minutes, and 48 of them later, it's just the end of the shift, and you move on.
So this brings up something I want to just explore with you, and that is the visibility of it. I mean, the fact that, if I'm running in a cloud and I'm a small business and my business model might be sensitive, we'll say, and I might not want the cloud provider to be able to see that operation. I'm looking at things like safeguard extensions. Maybe you can explain how that works, but the whole pretense of what you're talking about seems to say we're assuming the cloud provider is our friend and that we can trust they have our best interest and be able to watch and see and have visibility in everything we're doing.
I think yes and no. So one way, we have the system that can do the observing of what's going on. There's two parts I want to bring up here. One is we have the system that observes what's going on. That system could run in different places. It could run up in a separate cloud provider, or it could run in the same set of hardware and software you're running your application, in which case it's there's no kind of leakage of information. So you can deal with it from that standpoint. Second thing is understanding cloud providers, what security they provide and what security they leave to the as an exercise for the reader. So their basic thing is that we'll provide a boundary of security. For example, if you go to Amazon, to AWS or Google Cloud or any of these providers, their guarantee is your VM, we're not going to let other people directly break into the VM through the hypervisor layer, for example, and observe you that way. But the software running on that VM, that's your job to secure, and we're not going to even try because it's too hard. Basically, we have cloud services. There's orchestration services in the cloud. They may store logs for you, or store audit logs for all the API operations done, or things to bring up and down servers. They'll guarantee security of their APIs. That's their job. But the stuff that your software runs on, the things your stuff does, that's your responsibility. And so when we think about cloud provider, Kubernetes, for example, running in cloud, typically what you'll do is you'll get a base system of servers that are up in a cloud, and then you'll install the super Kubernetes software on them. And then that allows you to orchestrate use those servers effectively. Because it's on there, because there's always external components, cloud providers provide managed Kubernetes systems that help that system running on the cloud glue into the rest of the cloud, I guess is the easiest way to describe it. So if it needs to bring up another VM, it can do so.
So I think what you said there is that we have to understand whether we need to run our own Kubernetes or we can trust a managed instance by the provider. And that's a big decision point.
There's a decision point there. I think the main decision point the first decision point that people need to think about is, do I need to monitor this stuff at runtime? Most people who start this thing just want to build something, right? And so they start building stuff, and then security comes in as a little bit later on down the pipe, and they start. No one wants to get their software hacked, so they start, with the secure lifecycle, software development lifecycle stuff, scanning for vulnerabilities, and scrubbing their input and making sure that they're using good authentication systems and so on. But then on top of that, you need to. I think it's a little optimistic to assume that I can throw it over the wall and nothing bad is ever going to happen to it. It's kind of like saying I don't need to test my software, look at it because it has no bugs. And software vulnerabilities are just bugs in a way. So until we can ship bug-free software, you're gonna have them. And so if you're going to accept that you're going to have them, then you need to watch for them and monitor for them at runtime. And then the question is just, kind of how do you do that? How do you detect this stuff early enough that you can get it before the damage is done and you're getting a call from the FBI that says all your customers' data is out on the internet and it's been there for 6 months.
Interesting. So, going back to my other part of that question, safeguard extensions.
Yeah.
How does Kubernetes, and explain, what you would work with in that area if I wanted to add that layer of protection and how that works?
When you say safeguard extensions, can you tell me a little bit more about what you mean?
So the cloud protection and that obfuscates the visibility of what's going on inside your cloud instance. There's a couple products offered by that, and we've had a couple people on talking about how great it is. And I just want to know your thoughts on the integration of what you're doing with that.
In terms of when you're using a cloud product, my data, if I'm using it through a web API, is visible up through the chain because it's just traffic on the network. When you say safeguard extensions, I think you mean browser extensions, right?
No, it's a product that they use in the cloud or on a server to isolate blocks of memory and make it so that nobody can see them outside. They're operating in a protected environment.
I see. Yeah. Okay. So those sorts of things are there are a class of attacks that are relatively esoteric attacks, essentially, that where I can because I'm on a VM, sharing a VM with sharing a physical machine with another person, I can actually see see a certain amount through data leakage of what those other guys are doing. And they're very sophisticated attacks. You want to see rocket science. That stuff is rocket science. It's this fascinating area. And there are, and so you can build products that protect against that attack. And it's a good attack to prevent against. But what I think a lot of the bread and butter attacks, that we see tend to be kind of more someone deploys a vulnerable piece of software that allows remote code execution or doesn't scrub its input, or it's sort of that 90-10 rule. So I think they're really neat products. The safeguard extension, I just didn't recognize the term that you're talking about, but and it dovetails into something I think that's kind of important, is that everyone would love to have the silver bullet, the single thing that I could do that would solve it all. And that's, anyone who's been in security knows that defense in depth is really kind of what you need. There's no just running vulnerability stuff is not good enough. Just running runtime is not good enough. Just running, XYZ product is not enough. The way a friend of mine described it is you think about it as these threats coming in almost in a stream, and then you have a series of nets. And some of the things are going to get through some of the nets. But if the nets catch different things in different size and shape things, somewhere along the line, you're going to catch it. And then the other thing you want is to make sure that you have the systems that when something is caught, that you can figure out what the heck happened. Because like I said, it's kind of the tip of the iceberg oftentimes. If you think about like a ransomware attack, the ransomware attack is the last possible thing that happens in a long stage. Because for an effective ransomware attack to happen, I have to encrypt the systems, but there better be no backups. So I have to find the backup system and disable it. And then I don't want my ransomware to start and then get stopped so that they discover that I'm there. So I have to find the security systems and disable them. And all this takes time. So usually in these attacks, they're in your system for days, weeks, months. We've seen them, the average dwell time is almost half a year for people are in a system before the attack is actually detected. And so you want to be able to, when you see this alarm at the end of that chain, be able to work backwards and say, oh, they broke in over here, 60 days ago. And that was the vulnerability. And they're all over the place. So that tells you how I can clean up my mess. Yeah. And so
it sounds like
those systems is really important.
Yeah. Just kind of, we're getting toward the end of our time, but I wanted to give the opportunity to say, who are your customers? When do people reach out to you? If somebody's, we just talked all about the technology, the operations, who can say, hey, I might need to talk to you and get some help. Tell us about your customer and who can reach out to you and what types of things you offer.
Yeah, the people who seem to like us best are the ones who are born in kind of cloud native companies, people who are running Kubernetes, obviously, that's needed, and are getting started on their runtime security program. So it's sort of like my system's up, it's live, and I'm starting to realize, oh, this thing could be attacked. I'm not really watching it. That's a great, those tend to be the best customers. And that can be anywhere from small to very, very large. We have, kind of multinational, multi-million-dollar companies, and we have little companies that have, 3 guys and a dog.
Yeah. All right. Well, tell us how would they reach out to you? What's your email address or your website that they can hit on? It's
Spiderbat, SPYDERBAT.com. So it's like, we're from Austin, and Austin has bats. We have the largest colony of Mexican free-tailed bats. And
gotcha.
And so Spiderbats are a type of bat. And we were actually opening the bank account for Spiderbat. And the guy filled out the form and he wrote it with a Y instead of an I. And we thought, oh, that's cute. And so we actually changed the name of the corporation and stuff back when we really started.
Awesome. Well, thanks for joining today, Brian, and definitely been a pleasure. So thanks for
the thank you, Chris. Thanks for having me. It's been fun.
All right. Bye.
We hope you have enjoyed this episode of New Cyber Frontier. Remember to get involved. Often we think that someone else will handle privacy and security in the virtual world, but you are the only one truly in command of your virtual fate. Join our mailing list so we can keep you informed of breaking news and new releases. If you have an idea, if you have a question that you would like to hear answered, or if you want to get involved with our efforts, reach out to us at newcyberfrontier.com. We also encourage you to visit our sponsors' links, as they are the ones that really make this show possible. I want to thank each of you for supporting the show, and we look forward to seeing you back for the next episode of New Cyber Frontier.